Okay, guys, now let's add 1/10 and 5/100ths and find our sum. Alright, we'll simplify if we need to at the end, but at the moment, I want you guys to understand that in this example, we have no mixed numbers, so we don't have to worry about that. But we do have a big red flag. We see our denominators are not the same. Alright, we have one that's 10 and one that's 100. We cannot do anything until the denominators are equal to each other. So what we need to do is find the least common multiple, alright, of 10 and 100. Now, in order to find our common denominator, we're going to have to find the least common multiple. In order to do that, we'll need to find out what the multiples of 10 and 100 are and find the similarities. So, if we go down, we see 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30, 10 times 4 is 40, all the way down to 100. 10 times 10 equals 100. Now, if we go up here, we see that 100 times 100, 100 times 1 is 100, 100 times 2 is 200, so forth all the way. If you do 100 times 10, you'll get 1,000. But right here, we see that 10 times 10 equals 100, and 100 times 1 equals 100. So we have found our common denominator. Both numbers can go into 100. Now, this is where it kind of gets a little confusing, so I'll use a different color here. All right? Now, what we need to do is have 1/10 become equivalent to this fraction, and we need to have 5/100ths equivalent to this fraction. Alright, we just needed the common denominators, and we have them over here. So 5 over 100 remains the same, 5 over 100, 5 over 100, those are equivalent. It's the same fraction. Alright, now 1/10, alright, we will need to multiply 10 times 10. Alright, so 10 times 10 will give us 100, and that's what we see right here. Now, if we multiply the bottom denominator by 10 in this fraction, we will have to also multiply the numerator. So 10 times 1 is 10. Now, these fractions, 1 over 10 and 10 over 100, they are equivalent. They are the same number. The only reason we have changed them is to have common denominators, to have like denominators. Because once we have like denominators, just like we did in the past lessons, we are able to simply now just add the numerators. Once we add the numerators, 10 plus 5, we get a grand total of 15 over 100. Now we can even reduce 15 over 100. Now, since 15 and 100 are both divisible by 5, right, 15 divided by 5 is 3, and since we do it to the top, we can do it to the bottom. 100 divided by 5 is 20. And now we have simplified the expression. All right, so we are all done. The final answer should be 3 over 20. Now, I want to try one more fraction. One more with unlike denominators. So, now I want to try one more example, but instead of addition, we're going to do subtraction. Now, first thing we do is we check to see if they have any mixed numbers. In this example, we do not. But, just like in the last example, this example has different denominators. As we can see a 3 here, and we can see a 6 here. Now, just like in the other problem, we need to have a common denominator. In order to have a common denominator, we need to find out which number 3 and 6 have in common. So, let's go down and find the multiples of 3. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. Alright, so now let's go over to 6. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, and that should be good enough. Because I already notice that 3 and 6 have 6, oops, they have 6 in common, as well as the number 12. Now remember, we're looking for the least common multiple. So we're going to go with 6. And now 6 will be our new denominator. We have to make the fractions equivalent with the new denominator. So 1/6 is still equivalent to 1/6. That doesn't change. But let me get a new color. We are going to change 1/3 into something sixth. So 3 times 2 will give us 6, right? 3 times 2 will give us 6. If we multiply the bottom, we must multiply the top, all right? So the numerator, 1 times 2 is 2, and we are left with this new equation. We have common denominators, we bring over the operating sign, which is minus, and we can find the difference by easily subtracting the numerators. 2 minus 1 is 1, and we keep the same denominator.